Okay, in this video we're going to talk about geometry, some geometry. Okay, so the first thing we're going to talk about when it comes to geometry are polygons. So a polygon is a simple closed figure with 3 or more sides, and all the sides are straight lines. Okay, a regular polygon has all equal sides. So can you think of, based on that definition of a polygon and then a regular polygon, can you think of some examples of polygons? Polygon, by the way, poly means many, and I'm pretty sure that gon means angle. Many angles. So if we're thinking about a three-sided figure that has straight lines, what would you call that? Triangle. So one example would be a triangle. Triangle would meet the definition. A triangle that has all equal sides is called an equilateral triangle. And there's other kinds of triangles as well, but these are all the sides are equal. All the angles would then also be equal. If the sides are equal, the angles would have to be equal. Okay, so that's one shape. Now you can have triangles that don't have all the sides the same. So another example of a triangle would be a right triangle. A right triangle actually has a right angle. We're going to be talking more about right triangles. And you can also have triangles that have only two sides the same. If you have two sides the same and a third side different, does anybody know what kind of triangle that one is? It's isosceles. Oh no, I can't spell isosceles. Isosceles, something like that. Isosceles triangle has two sides the same, and a scalene triangle has all sides different. Okay, so that would be one example of a polygon, would be a triangle. What about another kind of polygon? Polygon can have more than 3 sides, so can you think of another kind of polygon? Maybe a square or a rectangle. Oh, you said rectangle?
Yeah.
Yes. So these are in the category called quadrilaterals. Quadrilaterals have 4 sides, and the most common are squares. And what's the difference between squares and rectangles? Yeah, so rectangles have 2 sides that are the same, and they're parallel, and we have 4 right angles. Those are 90-degree angles. We'll get to right angles in a moment. And then a square has all sides the same. So a square is to an equilateral triangle. Those are the ones we call regular. Regular means all sides are the same. So that doesn't mean that you can't have irregular. Irregular just means that they're not all the sides are the same. Okay, so yes? Okay, a trapezoid is still a quadrilateral. So actually here, that's a really great question. A trapezoid it's almost exactly like a rectangle, except for the fact that, well, it's not exactly like a rectangle at all, is it? It has 2 sides that are parallel, and these sides are not parallel, these other sides, right? In a rectangle, we have 2 sides parallel, and then in a trapezoid, we have usually it's the bottom. We call this a base 1 and base 2. And we'll get to the formulas for trapezoids as well in a moment. Okay. Yes. Isosceles. Yes, or it could be shorter. It's just that only 2 of the sides are equal, isosceles. Okay, so a trapezoid, since it has 4 sides, it's a quadrilateral. It's just irregular, right? And so we don't have, in terms of, and actually we'll get to that formula in a moment as well. Parallelogram, that's another quadrilateral. Parallelogram has, just like a rectangle, it has 2 sides that are equal. The parallel sides are equal, but it doesn't have right angles. So you see I have different angles. It's basically almost looks like a rectangle that's been smushed, right? Yes, pushed or nudged. It's like as if you take a box and you start to flatten it. So you no longer have the 90-degree angles in the corners. Okay? So that's what a parallelogram is. And then another quadrilateral example of a quadrilateral would be a rhombus. And a rhombus, it looks like a square. I think all the sides of a rhombus are the same, but again, the angles are not 90 degrees. So it kind of looks like a diamond shape. So that would be a rhombus. Rhombus. Okay? So lots of different kinds of shapes, and we'll go ahead and end there. I mean, you can go on. If you have 5 sides, that's a pentagon. 6 sides is a hexagon. We don't usually use 7 sides. Do you know how many, what do you call a shape that has 8 sides? Octagon. Okay? 9 sides would be nonagon. Nonagon. Okay, so why don't we just write those down? I'm not going to draw them. I'm not very good at drawing them, but a pentagon is 5 sides, and if they're all the same, it's going to be a regular pentagon. What did we say a 6 side was? 6 sides is a hexagon. Hexagon. Okay. Octagon would be 8 sides. I think it's nonagon. Nonagon is 9 sides. So you can see it can continue on and on and on and on. Eventually you get so many sides that it will look like, if you had an infinite number of sides, well then that's going to end up looking like a circle, isn't it? It's just going to be too many sides. Okay, and there's lots of things we could do with all those things, but we're going to talk about some specific concepts now. Perimeter versus area. Okay, and these are concepts that a lot of students get mixed up. The perimeter is going to be the distance around the outside of a figure. And what is the area? The area, this is always going to be in linear units, and I'll talk about what that means in just a minute. Okay, versus area. Area is the 2-dimensional space that is taken up by a figure. So with area, when we're talking about area of a rectangle, space inside, yes, so it's going to be the space inside the figure. And this is always 2-dimensional. Okay. What's that? Yes. Square units. Yes. Square units. Okay. So let's talk about a rectangle for a minute. So a rectangle has 2 sides that are equal and parallel to each other. So we call the long side usually the length, and we use the letter L for length. The short side we usually call the width. Doesn't have to be that way though, and we use the letter W. So if I wanted to find the perimeter, I would have to add up all the sides. So we use P for perimeter. P P is equal to, how many lengths do I have? 2 lengths, right? How many widths do I have? 2. 2 widths. You know, that's the same thing as length plus width plus length plus width. Oops, plus, not times. Okay, and I have 2 lengths and I have 2 widths. So that's where my formula comes from. I'm just adding up. For any other shape, this is just the perimeter of a rectangle formula, but for any other shape we would just add up all the sides. If it's an irregular shape or if it's a pentagon that has 5 equal sides, we would just add all of those sides up. That's exactly what I'm writing here. 2 times length plus 2 times width, right? Same thing. Okay, so the area of a rectangle is going to be the length times the width. And let me give us an example why that is. If I were to draw this rectangle right here, and let's say this is 2 units, I don't know, 2 inches, and then across is 4 inches, what is going to be the area of that? Well, every single square here is 1 square inch, or 1 inch squared. So I have 1, 2, 3, 4, 5, 6, 7, 8. Well, notice if I do 2 inches times 4 inches, I'm going to get 8 inches squared. So we use this exponent because I'm multiplying inches times inches, I get square inches. And that's how we know that something takes up area, it takes up square units. Okay, for the perimeter, if I want to find the perimeter of this, I'm going to go P for perimeter equals 2 times the 4 inches, because I have a 4 inches here and a 4 inches here, so that's how I get 2 lengths, right? Plus, how many widths do I have? There's my width, 2 inches, 2 times 2 inches. Here, notice I'm not multiplying inches times inches. So when I walk around the outside, the perimeter is always going to be just a straight line. That's why it's just inches. So the perimeter is equal to, this one is 8 inches plus 4 inches equals, how many inches altogether around the outside of the rectangle? 12 inches, right? So that would be the perimeter versus the area. Now let's talk about, that's the easiest thing to find the area and the perimeter of are going to be the rectangle and the square. A square, it just has to have all sides the same, right? But with a triangle, to find the area, now notice I'm going to actually turn the page. So we're talking about area and perimeter, but let's talk about a triangular shape. Okay, so again, if I draw my rectangle, if I draw a diagonal, this is called a diagonal, okay? A diagonal. A diagonal cuts my triangle, my rectangle in half diagonally, but it goes from one corner to the other. It wouldn't make sense to connect the corners here and here, so we're connecting opposite corners to cut the rectangle into triangles, 2 triangles. So what was the area? Who can remember the area of the rectangle? What was the formula that we just said on the last page? Length times width, right? Length times width. So now this is my length, here's my width. If I want the area of a triangle, I'm going to cut it in half or divide it by 2. And with a triangle, we actually call this the length, we call it the base, and we call the width here the height. And that's because we have to form a 90-degree angle. Remember, not all triangles have a 90-degree angle. If I draw an equilateral triangle, here's my base, but my height has to be at a 90-degree angle. So the height is actually not a dimension of the actual triangle. It goes from the base at a 90-degree angle to the top of the triangle. So the area of a triangle is 1/2 base times height. What I'm trying to just get at here is how we come up with that formula so that it's easier to remember. It kind of makes sense that it would be half of a rectangle, right? So that's where we get the 1/2 from. So let's say the base was equal to 24 inches and the height was equal to 5 inches. If I want to find the area of my triangle, well, first of all, I would actually need these other dimensions if I was going to find the perimeter. So let's say this is 13 inches and this is 13 inches. Who can tell me how I would find the perimeter of the triangle? What numbers would I have to add up? Yeah, and you're going to ignore the height. You're not going to consider the height because it's not part of the side of the triangle. So it'd be 13 plus 24, and those are all inches, inches, inches. That would be, does anybody know? Okay. Let's figure this out. 26 plus 24 inches would be 50 inches. Now, notice it's just going to be inches to the first power, not squared, because we're talking about the distance around the outside of the figure. The area is going to be 1/2 what times what? What two dimensions do I need there? I need the base, which is 24, and the height, which is 5 inches. Inches and inches. I forgot to put the inches, sorry. Okay, so I can go half of 24 is 12 inches, 5 inches. 12 times 5 is 60. Inches times inches is inches squared. So that would be the area. Did you have another question? What was the question that you had?
So you said that
Uh-huh.
we don't factor in the height. So
Yes.
when would we, or would we, is this something we have to worry about, or when would we have to factor in the height?
We'll get to maybe some other examples like that, but for now, just remember perimeter is the outside. The only reason why we're being given that height is because we don't have a 90-degree angle. This is not even an equilateral triangle. This would be an isosceles because two of the sides are the same. But in order to come up with the height, we needed that 90-degree angle. So we're using the height only for the purposes of the area, okay? Okay, so now let's talk about how we would find the area of a trapezoid, because that's another one that's on your sheet, okay? So let's talk about a trapezoid for a second. Trapezoid, okay? A trapezoid, it can have two parallel sides, but notice that they're not the same length, okay? So here, if this is 32 and this is 8, in order to have, I have to also have my height. My height is at a 90-degree angle because notice there's no 90-degree angles in the trapezoid. The height here is going to be 16, and I'm forgetting my units. So these are all meters, meters, meters. And then over here, 20 meters, and over here, 20 meters. Okay? First of all, what would be the perimeter of this shape? How would I find the perimeter? What would I need to add up? Add up all the outside. What would I add up? 20s. Uh-huh. Plus the 32. Oops, 32 meters. Plus the 8 meters. Sorry, I didn't fit that all in one line. So we're going to add that all up together. I know that 20 and 20 is 40. 32 and 8 is another 40. 40 and 40 is 80 meters, right? If I add up all those sides. Now the formula for a trapezoid is the area, for the area is 1/2, because that's the average, base 1 plus base 2 times the height. That is the formula for the area of a trapezoid. And basically, the reason why we have this formula is we're going to be taking the average of the two heights. Because notice, if I had a rectangle that was 16 by 8, that would fit inside this small space. If I had another rectangle that was 32 by 16, and I found those two areas, what I'm really doing is I'm going to be finding the average of the two rectangles. So this is how we find an average. If I have two scores, let's say you got an A on one test, a B on the other. If I was going to find the average of a 90 and an 80, would I just add the two numbers together? How would I find the average of those two? Or what would be the average of 90 and 80? Add them together and divide by 2. So the average would be 85. I know that because that's halfway in between 90 and 80. I didn't have to even add them together. But here, what I'm going to do is I'm going to take base 1, which is just one of the bases. So it's going to be 1/2. Base 1 is 32. Base 2 is 8. And then we're going to be multiplying by 16. Okay, so we add these together. 1/2, 40 times 16. And sorry, I'm not putting any units on these. Meters, meters, meters. This is something we tell our students to do all the time, and I'm failing to do it. Okay, so half of 40 is 20. 20 times 16. 20 meters times 16 meters is 320 meters squared. You always want to have meters squared for area. You want to have square units always for your area. And essentially, if I found the area of 16 or 8 by 16 and the area of 32 by 16, it would be the average of those two. Okay, so I was just talking about averages. Might as well just do that. 8 times 16, I'm pretty sure, what is 8 times 16? 8 times 16 is 128. 32 times 16 is 512. And if I find the average, I would add those two together, 128 plus 512, and I would divide by 2. Plus 128 equals 640. 640 divided by 2 is the same thing as that 320. So that's the reason why we have the area of a trapezoid is 1/2. We add the bases together, 1/2 the base 1 plus base 2 times the height in order to get the average of the two. So it's basically, yeah, that's what we're doing. We're finding the average of really two rectangles when we find a trapezoid, because you can kind of see you have these triangles along the side as well, right? Any questions about that? Any of that we've done so far? Okay, so for now, we're going to stop this one. We'll come back and do more geometry